Is given that the acceleration of a particle as seen from two frames and have equal magnitudes 4 meter per second square. So let's draw the diagram. So this is one frame of reference. So let this frame of reference be S1 and draw another frame of reference. So this frame of reference is S2. This frame of reference is S1, this frame of reference is S2. Acceleration of a particle as seen from two frames and have equal magnitude 4 meter per second square. So this is one frame of reference and particle suppose remains at position P. Origin to this position and origin to this position. So this is O and this is O dash. So this is OP and this is P to O dash. So this is acceleration of P with respect to S1. This is acceleration of P with respect to S2. So these are two frame of reference and given ki AP S1 is equals to acceleration AP S2 that equals to 4 meter per second square. Acceleration of the particle with respect to both the frame of reference is 4 meter per second square. That is already been given. So that is already been given. So we have to find what would be the bit. The frames must be at rest with respect to each other. The frames may be moving with respect to each other, but neither should be accelerated with respect to each other. The acceleration of S2 with respect to S1 may be 0 or 8 meter per second square. Acceleration of S2 with respect to S1 may be any value between 0 and 8 meter per second square. So we can write let the acceleration. So this is APS1 and APS2 already given 4 meter per second square and theta value varies between 0 to 180. Theta value varies between 0 to 180. So this angle OPO dash. So this OP, this is the particle and this particle angle with respect to both the frame of reference varies from 0 to 180 degree. So this is OPO dash angle. This is the particle P is the particle and this angle with respect to both the references varies from 0 to 180 degree. So if theta is 0 to 180 degree, so this 4 minus 4, if when we consider both the frames are having the same acceleration, so we can say ki 4 minus 4 if theta is 0, so this is 0 meter per second square. For theta equals to 180, this might be 4 plus 4, this is 8 meter per second square. So we can say, so theta, that depends upon theta value. So particle is at the position P, the theta value varies between 0 to 180. That's why the acceleration value changes from 0 meter per second square to maximum of 8 meter per second square. This is the minimum acceleration, this is the maximum acceleration with respect to relative acceleration. This is 0 meter per second square, this is the minimum acceleration, this is the maximum acceleration. So first bit is the frames must be raised with respect to each other. We cannot say that must be at rest, that varies between 0 to 8. So this is not correct. So frames may be moving with respect to each other, but neither should be accelerated with each other. Yes, this is accelerating. So this is also not correct. See, the acceleration of S2 with respect to S1 may be either 0 or 8 meter per second square. So that where theta varies from 0 to 180, theta value may be 30 degree, may be 60 degree, may be 90 degree, may be 120 degree. Theta value varies from 0 to 180. So minimum is 0, maximum is 8. So according to the theta value, acceleration value changes. So this is also not correct. So only last option is option D is correct. The acceleration of S2 with respect to S1 may be between 0 to 8 meter per second square. So acceleration of S2 with respect to S1 is 0 to 8 meter per second square. This is the minimum and this is the maximum. So acceleration value changes between minimum to maximum. So option D is correct. So option D is correct.